Okay, today we're going to look at doing AJAX, but instead of returning back delimited data, we're going to return either JSON data or XML data. What is the difference between the two? Well, the difference between the two is a matter of format. They both have very similar capabilities. They can be used to represent hierarchical data, whereas delimited data is very difficult to represent anything but a homogeneous set of data. So for example, if you're returning just a list of employees, for example, then you could probably do that with delimited data. Now, I'm going to show you an example of that in JSON and XML, but we'll talk a little bit more about what the differences are. But for example, if you wanted to display a list of employees, and for each employee show their supervisor and show the supervisor information, or show the employees grouped by department or something like that, that would be an example of hierarchical data, and that would be actually difficult to show in relatively difficult to show in delimited data. You'd actually have to have your program do the grouping itself, whereas the using XML and JSON, the hierarchy is sort of built within the data itself and the structure of the data. Here's a couple examples of JSON versus XML data. If we had, for example, a list of employees, the brace goes around the whole data set. There's a brace around there. Then we have the name of something. In that case, it's employees. And because employees is an array, we have the square brackets. Then we have curly brackets around data for that employee. Each element is enclosed in curly brackets, separated by comma, and we use first name, John, comma, last name, Doe, first name, Anna, last name, Smith, first name, Peter, last name, Jones. And we could go on more involved. For example, if we wanted to include spouse data, we could have the spouse data here, and that itself could be a collection of data. That itself could be something like this. Let me copy this in the Word and show you what I mean, because this example is fairly simple. Let's say we wanted an XML data to show by department. Let's not do spouses, let's do by department. So if we had our employees like this, what we could have is something like this. We could say department accounting comma employees be a group of then a group of these things, and they'll be included as part of a department. So this could be at the top level, we could have a grouping for our company. So we could do something like this. Company Zellers Inc. And that consists of a list of departments, and then we could have department repeated over and over again for as many departments as there were. I think this is right, but I hope you get the idea that we're having a hierarchy of data. On the top level, we have company, and on the next layer, we have a company that consists of a list of departments. Each department consists of a list of employees. So we sort of have a hierarchy there. Company on the top, department, and then employee. All right, that's very difficult or relatively difficult to represent using delimited data. Your code itself has to do the matching between department and employees and that sort of thing. Now, XML for this similar data would look like this. We'd use a collection of tags. And if we're going to modify our example again to reflect the different departments, would have company name equals Zellers Inc. So very similar to HTML, except these tags are tags that we make up to use in our own program. So they aren't a preset. That's what the X in XML stands for, extensible. Now I could have a department name equals counting. And that department would be comprised of a list of employees. Then we'd have an end department tag. And we would have department repeated anytime that we needed it. But you can see this shows a hierarchy. Both those methods show the hierarchy. If we want to know the department, it's the employees between the start and end of the department tag. The next department begins, then we know that those employees belong to that department, and so on. Okay, so we're going to look at the dictionary example that we looked at last week for translating mathematical terms from English into Spanish. We're going to look at that for both JSON and XML. Now, again, this example is a simple example. It doesn't really show the benefits of that, but it does show the form and the format of XML and JSON data. So let's first look at the JSON example. And one thing we're going to do in this is we're going to identify what is the same and what is different from the previous example. I will say that JSON is only used for the first query. Remember, we have two queries here. One, as you type in, it pulls up the data. JSON will be used for that. The piece of the puzzle that returns two values, an index and the name of the mathematical term. For this one, there's really no need to do anything since we're getting just one value back. All right, so we don't really need to do that in a JSON format. So let's look at the code for this and identify the similarities and the differences between this and what we did with delimited data. And I'm going to bring up the HTML, and I'm going to bring up the PHP. I'll briefly bring up Dictionary Inc. and Dictionary2.php to show you they're identical to what we used before. You give this one an index, it returns the corresponding Spanish term. In this case, we have our two arrays, and they're parallel arrays, which means that it matches up, each element in the English array matches up with something in the Spanish array on a one-to-one basis. So element 15 in the English array matches up with element 15 in the Spanish array. So that's no different than what we had before. All right, so let's look at the HTML, and we're going to first start on the client side and identify what in the HTML is different. All right, the form is the same. The HTML part of this is the same. We use the onKeyUp method so that when the user finishes typing in something and releases the key, remember, that's what puts it in the input buffer. So until then, it's not actually in the text name field. That gets the ball rolling. Now, we create the request object the same way as we did last time. We created it outside of any function because we want to use it across multiple functions. So we create the request objects the exact same way. Get words, first part of it is the same. All right. In fact, the whole get words is the same because we're going to be giving to our server-side code, we're calling it the same name, dictionary1.php, and we're passing a word on the query string. That's exactly what we did with delimited. All right, here's where the difference comes in with the response that comes back. So if ready state equals 4, that means that it's completed. The request is completed. Remember, that's a message that is part of the request object, part of that pipeline that indicates the status of the request. And a 4 indicates that the request has been completed. Now, the data comes back in response text. All right. That text is in JSON format, but it's not really a JavaScript object yet. All right. In order to fully use the JSON and the techniques used in JSON, we have to turn that into a JavaScript object so we can get the properties of it. So right now it's just a giant string of text. Doing this is what makes that a JavaScript object. All right. So we have in our variable response now the JSON version of what was in this response text. All right, this part's the same, this part's the same. Looping is about the same. The only difference is when we're creating the new option, all right, we pull, and we do this as long as response word list length, as long as I is less than response word list length. So we're looping through all of the things in the word list array in this JavaScript object. And for that JavaScript object, we're pulling for each element the word and the index. Let me show you the format that this data comes across in. So I'm going to go and I'm going to type in the address bar the script that gets called. Type in word equals AD. That's what we get back. We get back something that is a word list. All right. And the word list consists of an array of a bunch of words. Each word has the word itself, and it has the index. So this represents each element in the word list array. If we say word list length, we're going to get the number of items that are in this array. In this case, there's looks like 4 of them, starting from 2 and going through 5. All right. So this string, when converted to an object, becomes an object that contains an array called word list, and each element of that array has a word associated with it and an index associated with it. So in doing this, when we do this statement here, we're taking that string and we're actually making a JavaScript object. And that actually turns this, instead of just a string of data, it turns it into an object that contains a word list, and the word list contains, is an array that contains elements that contain a word and an index. So it's a JavaScript object. All right, let's look at the code that produces this. It'll be very similar to what we had in delimited. The only difference is what we're putting between the data is going to be different. All right, we're looping through the elements in the English array, and we're comparing to see if the position of the word that we've typed in the English array equals equal 0. The 3 equal, again, matches the data, the value of the data and the type of the data. Effectively, this statement checks to make sure that the word is equal to the first part of the word in the English array. All right. If this is our second word or more, then we're going to add a comma. Otherwise, we don't add a comma for the first one. And then we output a word string. And the word string equals what? Well, for each word, we're outputting curly brace, enclosed in quotes, the word word, a colon, enclosed in quotes, the value of the word, a comma, the word index, a colon, and then the value of the index. And that's exactly what we're outputting here. Curly bracket, enclosed in quotes, and the dot equals concatenation. So we're using we're not using the magic quotes here, all right, because we need to represent double quotes in our string. So we're using the single quotes, and we're simply concatenating each part of the string with the value of the data. And if we look at this, that's what we get as our output. We started out by creating our results start to say that the results from this is going to be a word list. And then we close it up down here. If there happen to be none, we output a JSON string that is also a word list, but the only word is no matches for this pattern, and the index is -1. Finally, whatever the string is that we accumulated, the word list part of it, the part where we define that this is a word list, the output for every word, which looks like this, we output to the client. And that's what the print results does. Okay, so how now does the print, that data get processed by the client? Well, we already shown that it gets taken and converted into a JavaScript object. Think of the response text in that point, it's sort of a dehydrated JavaScript object. It is all the data that's in the JavaScript object, but it's not a JavaScript object yet. It has to be brought to life. And that's exactly what this does. It takes that string and makes a JavaScript object out of it. All right, now we can refer to each thing. As we go through the loop, we want, in our JavaScript object, in the word list array, for the ith element, remember that word list is an array, and we look to see what the length of it is. So we want the ith element, and again, each time through that will increment. And what do we want from it? We want the word from it. So this is going to grab from the word list the first word element, and it's going to grab the word, and it's going to grab the index. And it's going to take that and make a drop-down option for it and add it to the list of the drop-down. It'll do that over and over and over until we hit the end of the array, in which case our drop-down has been formed. So type in something. Where's the cursor at? AB, it forms that list by parsing through that JavaScript object. So we're using the dot notation. The dot notation, again, goes from the object to each part of the object. And in the case of an array, which word list is, we have to supply a subscript for that part of the object. And then we can split it off into the actual data pieces. In this case, the word and the index. So that's an example of the JSON data in this example. All right, we're going to look now at the XML version. And the XML version behaves the same way as the JSON version, but the inner part of it is different. So if we type something in, I don't know why, but for some reason I made it yellow, the background. I think someone asked me in class about how to make a drop down, how to change the background color of it. So when this example was originally given, I think I just made that change. I don't really think it has anything to do with this problem. But as I type in something, again, same thing happens. And we get the result back. All right. Again, that second AJAX request is identical to the first two examples, so we're not going to look at that. We're only going to look at what's different between the other versions that we looked at in the XML. So let's look at the Java. Start looking at the client side for this. All right, let's edit this. We create our request objects the same way. We make the request the same way. Now that should make sense to you. I hope it does. Because in all cases, we're calling a PHP script and we're giving it the string or the part of the word that we want to do our query for. So that has nothing to do with how we're going to get the data back. So I hope it makes sense to you that in all these cases, this function is identical. The only difference between the different methods is what we do with the data when it comes back. All right. Let's look at the script that produces the XML. And first of all, let's look at visually what the results are. So if I go here and type in dictionary 1.php word equals A, what I get back is XML data. And there's rules with XML data. First of all, there always has to be one root node. Just like in an HTML document, there's an HTML tag at the beginning that indicates, hey, this document is HTML. We have to have a root node. We have to have one tag in that everything is contained in. And in our case, the tag is word list. Now, I just made this up. I just made up the word list, the item, and the word and index tag. So for each word that I return, I have an item tag, and the item tag contains a word, which is the actual value of the word that we're returning, and the index. Again, we need that index to do the final query. So this is what we're returning. A word list. XML, it contains a word list, contains individual items, and each item consists of a word and an index, and it's properly formed. If you made a mistake in this and you didn't do something right in the XML, you get an error when it tried to display it as XML. All right. Now you need to do what is called parsing the XML. By parsing, we mean taking and breaking it down into its different parts. All right. So we need to take and break this down into the array of items. And for the array of items, we need to break it down into the word and the index piece. Really, conceptually, anytime you have more than one piece of data, what you're going to do with the data is take the big piece of data that you got back that contains a bunch of things and break it apart into its various parts. We did that with delimited data by using the split command. All right, to take a delimited piece of data and split it into its various pieces, an array. We do it with JSON, where we take the JSON object and use dot notation to pull out different pieces of it. And we're going to use an XML parser that's built into the browser to parse or break apart this big XML file into its different pieces that we're going to use. So let's see the code that produces this. All right, it's going to look very similar to the JSON or the delimited code. The only difference is what we're putting between the words. In the case of the delimited data, we put semicolons and colons between the words and the index and the list of words. In JSON, we put the things appropriate for the JSON object notation. Here, we're putting them in tags. We have our main word list up here, and we add the end word list tag down here. Each time we find a match, we add to the results, again, using the dot as a concatenator, a tag for item, a tag for word, and the value of the English word, plus a tag, the end tags. Then a tag for the index, the end tag, and then finally the item end tag. So each one of these, each word is going to get one of these. An item tag that contains a word tag and an index tag. And all of those are within a word list. If we don't have anything, our item produces the word, no words match, and the index is -1. Okay, let's see how we parse this or break it apart. Again, the idea is the same. We wait till the ready state is equal to 4. That means that the request is completed. Now, one thing I forgot to show you in creating the XML. At the very top, we have to specify we're returning HTML. Not HTML, but XML. That's what this does. It sets the header, which identifies the kind of data we're returning. It sets the header of what we're returning. Now, we have to do that when we're returning XML. Why? Because we are creating an XML object that gets sent back. We're not sending back just an ordinary string. We're sending back XML data. Just like in JavaScript object notation, we were sending back a string, but we had to convert it to an object. Here, we're actually sending back an XML object. So in both those cases, we have to take the data that's returned and convert it to some kind of object so it can be processed. In JavaScript object notation, we return a string and the JavaScript turns it into an object. Here we use this content header to indicate that, hey, we're returning XML, and therefore the client will get back XML data. So the idea is very similar. We're going to loop through looking for, we say that the items equals to response.xml. Again, because we said the data type of the content type of the stuff we're returning is XML, the response doesn't come back in response text. It comes back in response XML. So we're pulling from the response, which is an XML object. We're pulling all the elements that have the tag item. So we're getting a list of each of these items. So the variable items, in this case, is an array of HTML tags. There's one element in the array for each item. We're going to loop through for every item in that items array. And then we're going to grab from that item, get elements by tag name, word, and do the same thing for index. Now, why do we have sub-0? We have sub-0 because there actually could be, not in our example, but in another example, there could be within the items tag, there could be multiple words. If, for example, we were translating not just from English to Spanish, but if we were translating from English to Spanish and French and Greek and Latin and so on, we could actually have several words in our XML file. So the sub-0 says, give me the first tag within that items array, within that item element, give me the first tag of word, and likewise index. Now we know because we made up our XML format that we only have that one, but we still have to indicate, hey, give me that. Now this returns what's called a node. All right, both of these return node, which is a node is just a little piece of an XML file. I am very sorry. My microphone took a dive. That's what happens when you do these things live, I suppose. In this case, items is an array of nodes because we're grabbing every item tag and putting it in an array. So items is an array of XML nodes that we go through. Word is a single XML node because we ask for only one of the nodes, the first one, and likewise index. So we have in Word, we have this XML node, and within index, we have this XML node. Well, we want the text that's associated with those XML nodes. And the way you do that is you say for that node, I want the first child, all right, which is the first thing in that node, and I want the value of that node. Now that's a long way around of saying that we want the value, we want the word that's included, we want the text that's included in the word. Now, why do you have to do that? You have to do that because, again, this node could itself contain a bunch of data and a bunch of tags and so on. We say it this way to say, hey, we want the text that's associated with that node. We want the first child, so the first thing that's part of that tag, and we want the value of it. And we do the same thing with index. We have the index of first child, and give me the node value of that. Now again, neither of these examples really illustrated the true benefits of these because I wanted to keep it simple and do a simple example and contrast it with the delimited data. One thing that you should notice is both the JSON and the XML the response that you get back from the server is much longer. All right. We're getting all this data back with XML. With JSON, we get all this data back. With delimited, we get this data back. So notice how JSON returns more data than delimited, and XML returns more data than both. Now, there's some advantages of XML, but again, the chief advantage of JSON is that it gives you data in a more compressed format. So if you're doing a lot of data transfer, you can save you some space. There's more that you can do with XML than JSON. There's something called XPath that allows you to take data that you return in XML and format it a certain way, but we're not really going to get into it. Just know that all three of them are options. Now, in this example, I probably would just do it with delimited data, all right? Because it's simple data, it's homogeneous data, that is each item in this list, all right, is like every other item. It has a word and an index. And there's no hierarchy here. So therefore, delimited is probably the right choice. But you should know how to do JSON and know how to do XML as well. All right. What I like to do with the rest of the time today is look at your last homework assignment. All right. Your last homework assignment is to actually integrate your code with data that you pull from a web service using an API. API is application program interface, I believe. And it's a way that you talk to other applications. It's sort of like the way that you say, hey, if you want this piece of data from this application, do this. So what we have here is we have open weather map, which allows you to get weather information about cities all over the world and including the United States. The API shows you an example of different things that you can get. You can get current weather data. That's the one I'm asking you to do, but you could also get other data, hourly forecast, one call API, data forecast. I think the reason that I picked this one is data you can get for free. All right. You do have to make a free account, and you do have to create a API key to let them know who is using this. But you should be able to do that for free. If you have any difficulty with that, let me know. So this shows you how to make an API call. This will be the script that you will call. This will be the JavaScript, what your JavaScript calls, what you make your HTTP, XML HTTP request to do. Now it's looking for, this one example shows latitude and longitude. I don't think, oh, okay, other features include geocoding. I was gonna say, I don't think we want to do that one, but we want to do by city name. Or yeah, by city name. To pull data from the city name, this would be the request that you would make. You'd have the user type in the city name, you would plug that into the queue part, and you would plug and you could just hard code your application API key into there. When you log on and create it, it will give you the API key. And again, you can copy this code. So this will fit in we're going to make an analogy. This will fit in here in this example. This is where we make the request. That's where you're going to make this call. Now here's the example of it and the data that you're going to get back. The data that you get back is JSON data. So you have to do like we did in the second example, pull this in, make a JavaScript object, and use the dot notation to access in your JavaScript object these different things. So for example, if we were to do this, if we had our code make a JavaScript object called obj, we would say obj.coord.lon, and that would return the longitude. obj.coord.lat would return the latitude. If we wanted the weather information, the main weather information in the description, we would say object.weather.main, that would give us drizzle, object.weather.description, that would give this light intensity drizzle. And you can pull other things from this temperature. One thing to note is this temperature is in Kelvin. All right, you get back the temperature in Kelvin. So you should convert that into either Celsius or Fahrenheit. And you can find a routine online to do that conversion. And there's other information you can pull, sunset, sunrise, and all that. I think I just asked for the high and low temperature or something like that, the predicted high and low or something like that, maybe just the current temperature. But you could pull, if you want to have real fun with this, you could pull, here's the high and low. If you want to pull other pieces of data from this just to practice, that would be great. You can make this as elaborate as you want to. One thing you could do in this is you could, have a different graphic. If it is, above a certain temperature, I don't know, show a thermometer with the temperature high. If it's below, show the thermometer with like ice coming from it. I don't know. You could actually test the values that you get back and display different graphics based on that. That's a little bit advanced, but if you want to have fun, please feel free to expand it beyond just what the request was. All right, so to get this to work, you have to go and register. I probably have already registered, so probably won't let me do it again. Let me see if I can log on. Oh, hey, I'm able to log on. Very good. This shows us other things that we can do with this, because obviously what they want to do is they want you to get used to it using the free capabilities and then show you that there's a lot of other capabilities that you can use besides, hoping that you'll upgrade yourself from the free subscription to the subscription you have to pay for. But if you wanted to incorporate weather on your website, you could do the very basic one, and then you could expand it to do the more elaborate if you needed to. API keys, this shows the value of my API keys for that. Status inactive probably is just that I have not been doing it for a long time. All right, so you'll get those API keys when you sign on. All right, are there any questions? Next week, again, we do not have class, and we do not have class in the finals week. Thank you for a good semester. It's been a little crazy. If you have any questions at all, please let me know via email. Other than that, take care. I hope to see you in future classes.